Have you ever been in a situation where the weather forecast called for sunny skies, yet it ended up raining all day long? You think, oh, if I only had my umbrella. But you know, guys, the job of predicting weather accurately is a difficult one because our atmosphere, it's constantly changing. You see, in order to predict the weather accurately for the hours and days ahead, weather forecasters must analyze information they receive from a number of sources, including local weather observers, weather balloons, weather stations, and satellites. Speaking of satellites, NASA has a train of satellites called the Afternoon Constellation, nicknamed the A-Train, which are orbiting the Earth, and they're collecting all sorts of data, including data that will help predict weather and climate change. Two additional satellites, CloudSat and Calypso, will soon be launched to be a part of that train. CloudSat will help improve weather prediction by studying the different aspects of clouds, as its name implies. Calypso will help predict climate change and how aerosols or particles affect the Earth's atmosphere. Later on in the program, Dr. Didier Tonray will tell us all about aerosols. But first, let's visit with Dr. Graham Stevens. He's the principal investigator on the CloudSat mission.
Thank you, Jennifer. We rely on accurate weather predictions for many activities. Farmers need to know the best times to plant and harvest their crops. Airplane takeoffs, landings and flight paths are scheduled according to local weather conditions. Weather forecasts alert people to severe storms that could endanger life or property. And most people want to know what the weather will be like as they go to and from work and school or plan outdoor activities. But do you think weather predictions or forecasts are always correct? What do you think causes errors in weather forecasts? You know, Jennifer is right when she stated that weather prediction is difficult. The atmosphere is constantly changing, and even though we receive weather data from a variety of sources such as weather stations, satellites, weather balloons and ground-based observers, it is still impossible to predict the weather correctly 100% of the time. One of the ways of improving our prediction of weather and climate is to develop new technologies that helps us understand how the atmosphere works. A new satellite that will help improve weather prediction is NASA's CloudSat satellite. CloudSat will provide the first vertical cloud profiling from space, improving weather and climate forecasts. Before we continue with the specifics of the CloudSat mission, here are a few questions I would like you and your peers to discuss and answer. What is a cloud? What types of clouds exist? Which clouds make which weather? Why is it important to study clouds? It's now time to pause the program. So how did you do with your questions? You know, clouds are all made of water. Sometimes they are made of tiny drops, far apart and held up by the wind. Other times they are made of big drops, held up for a while by very strong upward winds inside the cloud. In this kind of cloud, the drops become too heavy to stay up, so they fall to Earth as rain, or if it's cold enough, they fall to Earth as snow, hail or sleet. Clouds are classified based on three factors: their shape, the altitude at which they occur, and whether they are producing precipitation. Clouds come in three basic shapes: cumulus clouds, which are heaped and puffy, stratus clouds, which are layered, and cirrus clouds, which are wispy. Clouds also occur in three altitude ranges, specifically the altitude of the cloud base. High clouds, which occur above 6,000 metres and designated by cirrus or cirro, are cirrus, cirrocumulus and cirrostratus. Middle clouds, which occur between 2,000 and 6,000 metres and are designated by alto, are altocumulus and altostratus. Low clouds, which occur below 2,000 metres, are stratus, nimbostratus, cumulus, stratocumulus, cumulonimbus, and fog. I bet you didn't think fog was a cloud. It's a cloud that touches the ground. Clouds that incorporate the word nimbus or the prefix nimbo are clouds from which precipitation is falling. Can you think of another type of cloud? I'll leave the answer to that question up to you. So how many of you are wondering how to keep all those clouds in order? You know, it's tough even for me. That's why I use this globe cloud chart as a reference. You'll learn more about globe later in the program. So why is it important to study clouds? Clouds exert an enormous influence on our weather and climate. They are nature's way of moving fresh water from place to place on Earth. Clouds play a very important part in maintaining Earth's temperature. We need to understand how clouds reflect the sun's energy back into space or trap the Earth's energy in the atmosphere. We call this Earth's radiation budget. Using the CloudSat satellite for the very first time, we'll be able to measure the altitude and properties of clouds. The CloudSat radar will slice through the atmosphere, providing vertical cross-sectional view of clouds, and furnish new weather and climate data, including cloud layer thickness, cloud top and base altitude, and water and ice contents. Existing space-based systems only observe the uppermost layer of clouds and cannot reliably detect the presence of multiple cloud layers nor determine the cloud water and ice content. The penetration of CloudSat's radar into and through clouds will yield a new capability that fills a critical gap in existing and planned spaceborne observational systems. With this new technology, CloudSat will improve weather predictions, increasing the accuracy of severe weather, hurricanes and flood warnings. And now, Jennifer, I think the students are ready to size up the clouds. Back to you.